I'm Adam. I'm one of the co-founders of ZenML, and I pick you up and bring you through the whole journey of MLOps, how it evolved, and why we are there where we are right now. So first, I'm Adam. I'm a mechanical engineer. I studied at Stanford and in Munich, in Germany, and I'm the CEO of ZenML. ZenML has just announced its funding round with some popular investors, like we are. AIX Ventures, who is invested in Hugging Face and Weights and Biases, or Crane, who is invested in H2OAI, or D. Scully, who had today his keynote, is also invested in us, or somebody everyone should know, Demetrios Brinkman from the MLOps community is also believing in our vision. So this is ZenML, and we are an open source MLOps framework. Let me pick you up in the journey where we started with the whole MLOps and why we need it. So this is how a data scientist views machine learning. It's fairly simple, but not for everyone in the company. So engineering sees chaos. It's not really reproducible. It's super hard to bring and maintain in production. And the question is, where do we spend all of our time right now? So Chip is saying 10% is machine learning and 90% is engineering. Yes, that's definitely true. It looks fairly easy. So the step-by-step of machine learning is really a data collection step, a training step, and a deployment step. And this is how we normally were used to in software engineering. But the world isn't as perfect. So there are loops which are circling back, and the big variable what is changing now is data, not just code. So this is why DevOps is not applicable. We need MLOps. Let me give you an overview over what happened throughout the last year, which is completely crazy and really shocking for the whole industry. So GPT released, OpenAI was releasing JetGPT last autumn, and now we have really cool evolution steps, and tools are popping out everywhere. So what is the secret behind? So right now, OpenAI surpassed 1 billion in revenue, which is completely crazy for such a young company. But what is the secret behind? And this is the MLOps pipeline, what they built internally, still as a closed source solution offering APIs. As said, we are total believers in open source, and I would like to show you why. So where does it all start? Right now, we have these 3 steps, which I just mentioned, have hundreds of tools, and 90% of them are out there, right? So thank you, Charles, maybe he's here even, from Full Stack Deep Learning. This is a little overview over just the beginnings of what is out there. So for every step, for every vertical part of the machine learning pipeline, you have hundreds of tools which are specializing on specific use cases or niche problems. And this is very important. By the way, this is also an argument why the hyperscalers, the SageMakers of this world, the Vertex of this world, they by definition cannot give you the best solution in every niche problem. This is why the justification of all these tools out there is given. And this is something we have to make use of. And luckily, most of them are open source. It's just too much happening. The fragmentation in the market is crazy, and we don't really have a single source of truth. And it should be so easy, because I think we are very sophisticated already and have these kind of development circles we ran through all over the last software engineering decades. But yes, we have there has to be something which is combining everything. Why is it important that we have so many tools for every step? There are so many different stack components, how we name it. For every pipeline step, there are more. Let's for example, here, see a pipeline. What is an MLOps pipeline? MLOps pipeline is combining all of these things and circling back and referencing back to other tools, and it's all a variable of data in between. So this is obvious why the dimension of the problem is just exponential, and we just cannot bring it all together. But still, the ML pipeline should be fairly simple with certain steps. So we have many definitions. I just had 3. Now we have 5. So you get the point. We have a consequence of like more tools put together. And ZenML, this is what I would love to introduce now, is stitching these tools together on an abstraction layer for machine learning engineers and platform engineers. So we are decoupling the code from the infrastructure, make them exchangeable. So if you would like to delay your MLOps decision, whether you would like to use weights and biases or MLflow or Kubeflow or Airflow or whatever, we can make it so modular that you can decide later and just start building. And this is the beauty of it. So we are fully open source. You can even ingest your own code. We give you a nice experience and the single source of truth, which will give you reproducibility, auditability. We are connecting everywhere between these dots of the pipeline and make warm starts possible. So caching is possible, for example. You can collaborate with your colleagues way better. So let me quickly show you how ZenML works. So it's very simple. So you write your code, as I said, it's completely detached from the infrastructure, so you don't have to adapt to specifics. You write your pipelines in Python, then you connect it to your infrastructure with whatever stack you have, and you can still delay the decision as such. So you can revert that decision later, and then you have everything together in one platform. And this is what ZenML is, open source. And we also have a cloud version, obviously, where we manage it for you, and even other tools. So let me quickly, 3 minutes left, show you some data snippets. So if you would like to switch your artifact store from S3 to Azure, for example, this is how it looks like right now. I think it looks familiar to everyone. So, but you have to rewrite it, right? Let me give you a second example. If you would like to have a tool implementation, like with an artifact store from S3 to Azure, this is how it looks like. And now, this is how we do it with ZenML. We define step functions where you just ingest where you want to be. So, for example, from S3 to Azure, it's the same code, and you just are so far abstracted from your code, from your infrastructure, that you can even use the same code, which is really cool. So you can use Genesis Cloud, you can use TensorRent, you can use Azure on-prem, GCP, even SageMaker, Databricks. So this is the beauty of it, that you stay independent, and with the flip of a switch, you bring your code, which you have in like a laboratory environment, into production quite quickly. And this is the second example, switching an artifact store. So you can see the only thing what we are changing is literally S3 to Azure. Same code, same logic, same syntax. This is ZenML. Thank you so much. Please book a demo. And I'm very looking forward to welcome you also in our booth in the back. Thank you so much.